Tonight, we begin our journey toward Mars, the red planet. It glows faintly in the dark sky, a tiny ember suspended in the cold of space. From Earth, it looks so still, so small, but it is a world of ancient power, a place where volcanoes once rose taller than any mountain in the solar system, and where time itself seems frozen in rust and silence. As we drift toward it in our imagination, picture the scene. The vast blackness of space, stretching in every direction, the sun shrinking behind us, and ahead, a growing red dot, Mars, its thin atmosphere catching the faint light like a dusty halo. Over the next few hours, we will walk its frozen plains, climb its sleeping volcanoes, and uncover the traces of a fiery past that once made this quiet planet burn with lifelike heat. So settle in. Breathe deeply. Tonight we travel not through space, but through memory, the memory of fire, stone, and time. Before we begin our descent, a small favor from one dreamer to another. If you'd like to support this growing channel on its first steps, consider subscribing. It helps us reach our first 1,000 dreamers and keeps these quiet stories alive. Now, let's begin the journey. As our spacecraft approaches Mars, the red planet fills the window. It is smaller than Earth, just over half its size, and lighter too, with only about 38% of Earth's gravity. You would feel your weight reduced to almost a third of what you're used to. Every step would feel like a bounce. The color that gives Mars its famous name comes from iron oxide, rust, covering its surface. Billions of years of exposure to thin air and sunlight turned its rocks into shades of red, orange, and brown. That red dust floats in the air, settling on everything like a quiet snow. The atmosphere is whisper thin, mostly carbon dioxide, with a trace of nitrogen and argon. You couldn't breathe it, nor could it carry much sound. A conversation shouted a few meters away would fade into near silence. Yet, this thin air shapes the planet's weather: gentle winds, sudden dust storms, and delicate morning frosts. As we orbit above the surface, the sight is breathtaking. Vast canyons, mountain ridges, frozen plains. From here, it feels like a planet built to last, patient, scarred, but waiting. To understand Mars, we must go back nearly 4 billion years. In its youth, Mars was alive with volcanic activity. The crust was still thin, and molten rock surged upward through cracks and weaknesses, spilling across the surface. Unlike Earth, Mars does not have plate tectonics. Its outer shell does not drift or divide. This stillness meant that when lava erupted in one place, it did so again and again, piling up over millions of years. The result was not sharp, violent peaks, but gentle, enormous mountains. Volcanoes so wide, they could stretch beyond the horizon. In those early days, the air was thicker. Volcanoes released gases, water vapor, carbon dioxide, sulfur dioxide, that filled the sky, trapping heat, and perhaps even allowing liquid water to flow. For a brief time, Mars might have been warm and humid enough for rain, rivers, and shallow seas, but the fire that gave it life would one day lead to its stillness. Every eruption released energy from the planet's core, and little by little, Mars began to cool. From orbit, Mars looks like an open book. Its surface is not erased by oceans or forests as on Earth. Instead, it keeps every chapter of its past visible. Craters, plains, and channels form a geological diary that stretches across billions of years. The northern hemisphere is low and smooth, suggesting vast ancient basins, perhaps once filled with water or lava. The southern hemisphere, in contrast, is high and heavily cratered, older, rougher, untouched for eons. Between them lies the dichotomy boundary, a scar that separates the planet's two worlds. Then there is Valles Marineris, a canyon so immense it dwarfs our Grand Canyon, stretching over 4,000 kilometers long and 7 kilometers deep. Scientists believe it formed as the crust stretched and cracked under the weight of nearby volcanoes. Standing at its edge, you could look across a horizon that curves with the planet. Mars, in every line and shadow, tells us its story, one of pressure, heat, and patience. Now our path leads to the largest volcano in the solar system, Olympus Mons. It rises 22 kilometers above the plains, nearly 3 times taller than Everest, and its base spans more than 600 kilometers, wide enough to cover the entire state of Arizona. Yet, despite its size, it is not a sharp peak. It slopes gently, the product of countless slow eruptions that spread lava outward rather than upward. Scientists believe Olympus Mons grew over hundreds of millions of years, fed by a single, stationary hotspot in the Martian mantle. Because Mars has no moving plates, this volcano never drifted away from its heat source, allowing it to build higher and higher until it reached the sky. At the summit lies a vast caldera, a depression nearly 80 kilometers across, formed when the lava chamber beneath collapsed after an eruption. Today, it's silent, but its scale reminds us of what Mars once was, a world of immense heat and pressure, shaping itself from the inside out. Imagine standing there, at the summit of Olympus Mons, looking down at the curve of Mars below. The horizon stretches far and thin, the sky pale orange. The planet sleeps now, but its history still hums beneath your feet. To the west of Olympus Mons lies the Tharsis Plateau, a massive volcanic region that once reshaped the entire planet. Roughly the size of North America, Tharsis is home to several enormous volcanoes: Arsia Mons, Pavonis Mons, and Ascrius Mons, each towering over the plains like ancient watchtowers. The Tharsis Bulge is not just a group of volcanoes. It is the reason Mars looks the way it does. The rise of this plateau may have tilted the planet's axis, changing its climate, and perhaps even redirecting the flow of ancient water. Lava from Tharsis spread for thousands of kilometers, covering valleys, burying craters, and reshaping entire hemispheres. When Tharsis erupted, it changed the sky. The gases released could have thickened the atmosphere, warmed the surface, and triggered a temporary greenhouse effect. For millions of years, the world may have been alive with storms and rain. Now, it is still, a continent of frozen fire. The Tharsis volcanoes stand like giants in the dusk, their shadows stretching for hundreds of kilometers across the plains. And as the sunlight fades, we leave this region behind, drifting eastward toward the deep scars carved by both fire and time. As we drift eastward from the Tharsis Plateau, the land begins to tell new stories, stories carved not by water, but by lava. Across the plains lie vast channels that once flowed like rivers. Yet they were rivers of molten rock. The lava that poured from the Tharsis volcanoes spread for hundreds, sometimes thousands, of kilometers before cooling. Because the gravity on Mars is weaker and its atmosphere thinner, the lava could move farther, more freely than on Earth. Imagine standing above one of these channels, a winding, frozen sea of stone. The walls rise like riverbanks, and the floor ripples with the patterns of flow. From orbit, they look eerily familiar, resembling dried riverbeds. Early scientists even mistook them for proof of ancient water, but later measurements revealed their volcanic origin. Long corridors, where heat once flowed like a heartbeat through the planet's crust. Some of these flows are connected to lava tubes, hollow tunnels left behind when the outer layer of molten rock cooled and hardened, while the liquid within continued to flow. Many of these tubes remain intact, stretching for miles beneath the surface. In the future, they may serve as natural shelters for explorers, places shielded from radiation and dust storms. As you imagine walking through one, the air still and thin, the echoes of the planet's fiery past surround you. Each wall tells the same story, that Mars once moved, breathed, and flowed with quiet power. Volcanism is the heartbeat of a planet, a sign that its interior is alive, circulating heat and energy. On Mars, that pulse once beat strong, but as the planet aged, it began to lose its internal warmth. Smaller than Earth, Mars cooled faster, its molten core solidified, its energy faded, and with it, the power to reshape itself dwindled. The last great eruptions may have happened hundreds of millions of years ago, recent in planetary terms. After that, silence. The crust thickened, the mantle quieted, and the great volcanoes fell asleep. Yet, even in stillness, traces of warmth remain. Some scientists believe that deep beneath the surface, magma pockets might still exist. Not enough to awaken Olympus Mons, but enough to hint that the planet has not gone completely cold. This cooling changed everything. Without internal heat, Mars lost much of its magnetic field, and without that field, the solar wind, a stream of charged particles from the sun, began to strip away the atmosphere. Slowly and visibly, Mars's breath was taken from it. Now, it stands as a monument to time, a reminder that even planets, like living things, have lifespans of fire and rest. In the age of volcanoes, Mars was also shaping its own sky. Every eruption released gases trapped within the mantle: water vapor, carbon dioxide, sulfur compounds. These gases thickened the atmosphere and warmed the surface through the greenhouse effect. For a time, Mars may have been covered in clouds, with rain or snow falling softly over dark basalt plains. Volcanoes, paradoxically, gave the planet both life and stillness. The same gases that warmed Mars also reacted with its surface, forming minerals that trapped the planet's moisture. As volcanic activity waned, the production of new gases slowed. The atmosphere, no longer replenished, began to thin. Solar radiation broke apart the molecules that remained, and the wind carried them away. What's left today is a ghost of that ancient sky, a delicate veil of air, 100 times thinner than Earth's. Yet, traces of the old warmth linger. We find minerals that could only form in liquid water. We find channels that could only have been shaped by flowing currents. These are the fingerprints of volcanoes, proof that the breath of fire once gave birth to rain. To the east of Tharsis lies one of the most astonishing sights in the solar system, Valles Marineris, the Grand Canyon of Mars. But calling it a canyon hardly does it justice. It stretches over 4,000 kilometers long, as wide as the United States, and plunges 7 kilometers deep in places. If you stood at its edge, the opposite rim would be beyond the curve of the horizon. Scientists believe that Valles Marineris formed when the crust of Mars cracked under the pressure of the rising Tharsis Plateau. The planet's outer shell stretched and split, creating a network of fissures that widened over time. Some areas may have been deepened by lava flows or collapsed ground, others by erosion from ancient water or wind. The canyon's walls reveal layers upon layers of rock, a geological library of Mars's history. Each band of color represents a different era: dark basalt from lava flows, lighter sediments from dust, and possible ancient lakes. If you could touch those walls, you'd feel billions of years of change beneath your fingers. Now the canyon lies silent, but not lifeless. Landslides still reshape its slopes. Dust devils dance across its floor, and when the sun sets, shadows stretch for miles, turning the chasm into a world within a world. Unlike Earth, Mars has no oceans or forests to erase its past. Its surface keeps every mark, every crater, every scar. It remembers everything. That is why scientists call it a planet of preservation. The story of its youth, its heat, its storms, its rivers, and eruptions remains frozen in time. Orbiters and rovers act like historians, reading those memories layer by layer. The rover Curiosity, for example, found ancient clay minerals in Gale Crater, proof that water once pooled there, long after the volcanoes had quieted. Perseverance, exploring Jezero Crater, searches for chemical traces of life that might have survived in that same volcanic aftermath. Each discovery rewrites what we thought we knew about Mars. It's not a dead world, it's a world that rests, a world whose memory is written in dust and rock, waiting for us to read it gently, patiently. As we leave the canyon and drift northward, we carry that thought with us, that Mars is not just a planet frozen in time, it is a time capsule of the solar system itself, keeping the echoes of fire, wind, and silence intact for those who wish to listen. As the last volcanoes quieted, Mars began to change in ways that would shape its destiny. A planet's warmth comes from the energy within, radioactive decay, friction, molten metal flowing in its core. For Mars, much of that energy faded too quickly. Its smaller size meant less internal pressure, and its surface, exposed to space, lost heat faster than Earth's. Over millions of years, the mantle thickened, and the core cooled. The magnetic field that once shielded the planet weakened, then disappeared altogether. Without it, the atmosphere, already thin, became vulnerable to the constant bombardment of the solar wind. Imagine that invisible stream of particles, rushing from the sun at hundreds of kilometers per second, brushing against Mars, stripping away molecules one by one. What began as a sky dense enough for clouds became the fragile veil we see today. With each passing century, the planet grew colder, drier, and quieter. The last traces of volcanic warmth sank deeper below the crust, and Mars entered a kind of cosmic sleep, not dead, but dormant, wrapped in dust and silence. Long before the volcanoes went silent, Mars likely had water, not in great oceans like Earth, but in lakes, rivers, and shallow seas that glimmered beneath its orange skies. The evidence lies everywhere: channels that once carried liquid, deltas that spread like fans, minerals that can only form underwater. But as the atmosphere thinned, the surface pressure dropped below the point where liquid water could survive. It began to evaporate or freeze, disappearing from the plains and collecting at the poles. Some of it escaped entirely into space. The rest became ice, locked beneath layers of dust. Today we can still see this frozen legacy. The northern and southern caps of Mars gleam with white, composed of water ice and frozen carbon dioxide, what we call dry ice on Earth. Every Martian year, as the seasons change, these caps grow and shrink, breathing in rhythm with the planet's orbit. It's humbling to think that Mars once had the right conditions for rivers to flow, and perhaps for life to take hold, and that all of it was lost, not through catastrophe, but through time's slow patience. With little atmosphere and no oceans to anchor it, Mars became a world ruled by dust. The fine particles of iron-rich sand cover nearly every surface, drifting endlessly with the weak Martian winds. This dust is lighter than talcum powder and electrically charged by sunlight. It sticks to everything: landers, rovers, even the solar panels that power them. Sometimes, the winds rise into storms that circle the entire planet. In 2018, one such storm engulfed Opportunity, a rover that had been exploring Mars for 15 years. The skies darkened for weeks. The sunlight faded, and the rover's batteries grew cold until, finally, it fell silent. A small machine lost in the endless dusk. But these storms are not just destructive. They are part of the planet's rhythm. They redistribute heat, carry moisture, and even sculpt the dunes that shift across the plains. Some last for hours, others for months. Yet when they clear, Mars returns to its fragile calm, a thin red world beneath a pale sun. To live here would be to live in constant conversation with the dust, the planet's oldest and most persistent voice. At the edges of Mars, where sunlight barely reaches, lie the polar caps, frozen monuments of carbon dioxide and water ice. Each winter, the poles expand as the atmosphere itself condenses, freezing directly onto the surface. In spring, the ice sublimates, turning from solid to gas, and drifts back into the air. This seasonal breathing is so powerful that it slightly changes the planet's air pressure and even its rotation. The layers of these caps are like rings in a tree. They record climate changes, stretching back millions of years. Dark bands mark dust storms and volcanic eruptions. Bright layers mark periods of calm. By studying them, scientists can glimpse the ancient climate of Mars, a history written not in ink, but in frost. Beneath the surface, radar scans have revealed possible reservoirs of liquid water trapped under the ice. It's extremely salty and cold, but still fluid. If confirmed, it could be one of the last refuges for microbial life on the planet. Standing on this frozen plateau, beneath a thin orange sky, the horizon glowing faintly red, one would see a landscape both alien and familiar, a reminder that even in the farthest cold, there is memory and rhythm. Though the air on Mars is faint, it still breathes in patterns of wind and sunlight. At dawn, the planet glows softly, the cold ground radiating heat from the night. Wisps of fog gather in low craters and valleys. By midday, as the thin sunlight warms the surface, those mists vanish into the air. Tiny whirlwinds, dust devils, spin across the plains, rising hundreds of meters high. Each of these devils leaves behind delicate trails, visible from orbit. Some of them pass near robotic explorers, brushing their panels clean, almost as if the planet were tending to its guests. Others travel across dunes and plains, redrawing the landscape grain by grain. At sunset, Mars turns gold, then violet, and finally deep crimson. The sun appears smaller than on Earth, and the twilight lingers long after it dips below the horizon. In those moments, the planet feels alive, breathing in light and dust, in its own slow rhythm. If you were there, you'd hear nothing but your own heartbeat and the faint hum of your suit, yet somehow it would feel full of sound. The sound of a world that has found peace in silence. Long before spacecraft ever touched its surface, Mars was already a mystery to us. For thousands of years, it appeared as a wandering red light in the night sky, unpredictable, fiery, and captivating. To the ancients, it was a symbol of war and energy, a moving ember among the stars. But in truth, it was the first planet that made humanity look outward in wonder. In the 17th century, when telescopes became powerful enough, astronomers like Christian Huygens began to sketch dark markings on Mars's surface, hints of its rotation and terrain. Later, in the 19th century, Giovanni Schiaparelli mapped what he called canali, meaning channels. When translated into English as canals, it sparked a global fascination. Perhaps Mars was not barren, but built by intelligent life. Writers like H.G. Wells and Edgar Rice Burroughs turned that idea into stories of civilizations, deserts, and distant wars. Though the canals were illusions caused by the limits of early optics, they captured something deeper, our longing to connect with another world. Even now, when we look at Mars through our telescopes, we feel that same pull, a quiet awe that somewhere, in the endless night, a neighbor waits. By the 1960s, our curiosity had grown restless. The first spacecraft were launched toward Mars, silent emissaries crossing the void. In 1965, NASA's Mariner 4 flew by and sent back the first close-up images. What it revealed shocked the world. No canals, no cities, only craters and endless plains. It was colder and emptier than we imagined, but it was real. A world preserved. Later missions, Mariner 9, Viking 1 and 2, orbited and landed, mapping volcanoes, canyons, and valleys. Mariner 9, in 1971, arrived during a massive dust storm that shrouded the planet for weeks. When the skies cleared, it captured the first clear view of Olympus Mons and Valles Mariner, confirming that Mars was once a world of immense geological power. The Viking landers, in 1976, conducted the first experiments, searching for signs of life. The results were inconclusive. No proof, but no absolute denial. They found a world that had once been friendly to water. And maybe, just maybe, to something living, those first robotic eyes changed everything. Mars was no longer a myth. It was a place we could reach, touch, and study. In the early 2000s, Mars began to receive new guests, explorers that could move, think, and endure. The twin rovers, Spirit and Opportunity, landed in 2004, designed for missions of 90 days. They lasted years. Spirit wandered across volcanic plains, finding rocks altered by water, proof that Mars once had the chemistry for life. Opportunity explored Meridiani Planum, uncovering small spheres of hematite nicknamed blueberries, formed in liquid water long ago. Then came Curiosity in 2012, larger, stronger, capable of drilling and analyzing the Martian soil. It discovered ancient riverbeds and clay minerals, signs that Mars once had lakes and a stable climate. Later, Perseverance joined in 2021, exploring the Jezero crater, a fossilized river delta that may still hold chemical clues to ancient life. Each rover carries more than tools. They carry stories of endurance, patience, and human curiosity. When Opportunity finally fell silent in 2018 after a dust storm, its last message read, "My battery is low, and its set's getting dark." Those words echoed across the world, a reminder that exploration is not about conquest, but connection, a conversation between worlds. In 2018, another traveler arrived. InSight, a stationary lander designed not to see the surface, but to listen to the heart of Mars. It carried a seismometer to detect quakes, not earthquakes, but Marsquakes. For the first time, we could hear the vibrations of a planet millions of kilometers away. The data revealed that Mars still stirs. Its crust shifts, its interior echoes faintly, and the planet hums with a deep, subtle rhythm. InSight also measured the temperature beneath the soil and the faint magnetic traces of its long-lost field. Together, these findings told a simple truth. Mars is not dead, it sleeps, but dreams. When dust eventually covered InSight's solar panels, its power faded, just like Opportunity before it. But what it left behind was invaluable. A soundscape of another world, the quiet tremors of a planet remembering its own heartbeat. And even in that faint pulse, we find something familiar, the rhythm of endurance, of change, of life that refuses to vanish completely. Now, humanity prepares to go there in person. Space agencies and private companies alike plan for the first crewed missions to Mars, journeys that will take months, with astronauts facing radiation, isolation, and the thin atmosphere of a frozen world. Yet, the dream persists. The goal is not just to visit, but to stay, to build habitats, extract water from ice, grow food in Martian soil, and learn to survive under a sky tinted by rust. The challenges are immense, but so are the rewards. Each rover, each lander, each orbiting satellite has already laid the foundation, mapping where humans might one day live and breathe, even if through a suit. Standing on that horizon, beneath a sun that burns half as bright, future explorers will look up and see Earth, a pale blue dot in the distance. And perhaps they'll feel what we feel now, that Mars is not a place of endings, but of beginnings. It will be the next chapter in our shared story, one written in dust, silence, and courage. The first people to walk on Mars will find a world both beautiful and harsh. The sunlight is weak, the air thin, and the ground coated in fine, sticky dust. The temperature swings from summer warmth at noon to bitter cold by night. Radiation from space seeps through the sky, unseen and relentless. To survive, humans will need to live beneath protection, perhaps in lava tubes, those ancient tunnels carved by flowing rock beneath the Tharsis plains. They could become natural shelters, safe from storms and radiation. Inside them, explorers might build habitats filled with breathable air and warmth, like lanterns glowing beneath the crust. Food will come from greenhouses, sealed against the cold, powered by sunlight and nuclear energy. Water can be drawn from underground ice or recycled endlessly. Every breath, every sip will be precious, a reminder that life here is not to be taken for granted. And yet, the first step on that red soil will echo louder than any sound. Humanity, for the first time, will have touched two worlds. The fire that once slept within Mars will burn again, not from the planet itself, but from the hearts of those who walk upon it. For decades, scientists and dreamers alike have wondered, could we ever make Mars more like Earth? The idea of terraforming, transforming a barren planet into one that can sustain life, is as old as science fiction. The basic principle is simple: warm the planet, thicken the atmosphere, and release the frozen water locked in its soil. But in practice, it is a challenge that spans centuries. Some theories suggest releasing greenhouse gases to trap heat, melting the polar ice caps to release carbon dioxide and water vapor. Others imagine giant orbital mirrors reflecting sunlight onto the surface, or microbes engineered to thrive in the Martian soil, slowly producing oxygen. Yet, recent studies show that Mars may not have enough resources to sustain such change. Its gravity is too weak to hold a thick atmosphere for long. Its core no longer generates the magnetic field needed to protect it from the solar wind. Perhaps Mars is not meant to be changed into another Earth. Perhaps it is meant to remain itself, a quiet, ancient world that teaches us humility. Instead of remaking Mars, maybe we must learn to adapt ourselves to it, to live gently, without trying to awaken what has chosen to rest. Every discovery on Mars, every sample of rock and dust, reminds us of our own planet's fragility. Mars is what Earth could have been, or could still become, if its balance ever broke. A once active world that cooled too soon, that lost its shield, its water, and its warmth. Studying it helps us understand how planets evolve, how atmospheres breathe, and how life finds its foothold. We learn how to detect the signs of ancient rivers, how to listen to the hum of a world's crust, how to read the memory of stones. More importantly, Mars teaches us about patience. It reminds us that time moves differently on a planetary scale. What feels eternal to us, a lifetime, a civilization, is only a blink in the life of a world. It shows us that even after billions of years, beauty remains, written in dust and silence. So as we explore Mars, we also explore Earth anew, understanding not only how planets live, but how they endure, even as we send machines and data to its surface. Mars remains personal. It's the star we point to when we speak of dreams too big to fit within Earth. And perhaps that's what makes it special. Not that we might reach it, but that it has always reached us first. There is a quiet magic in knowing that Mars is always there, rising and setting in our skies. On clear nights, you can see it, a steady, orange glow, brighter than any star. Every culture that has looked up has given it a name, a story, a meaning. The Romans saw the god of war. The Egyptians saw a wandering soul. The Navajo called it Masa, the keeper of fire. Now in our age, it has become a symbol of something different, not of war, but of wonder. It stands for exploration, endurance, and curiosity. Children who watch it through small telescopes may one day walk upon it. The red planet connects us, across time, across language, across distance. Now, as our journey nears its end, we return to the quiet truth at the heart of Mars. Beneath its frozen crust and dusty plains, the planet sleeps, the volcanoes rest, the winds whisper softly across dunes that have not moved in centuries. The world that once burned with fire now glows with memory. Mars does not need to wake for it to be alive. Its stillness is its beauty, a reminder that every flame, once spent, becomes light in another form. The same elements that built its volcanoes and carved its canyons are the ones that built us. Iron, carbon, silicon, oxygen. We are not strangers here. We are made of the same dust that paints its horizon red. So, as you breathe slowly, imagine the world turning beneath you, a red gem in the darkness, circling the sun in perfect silence. The story of Mars is not over. It has only entered its quiet chapter, and in that quiet, we find rest too. And to those who have already joined this small constellation of dreamers, thank you. Your presence lights this journey, block by block, word by word. If you haven't yet, consider subscribing. It helps us reach our first 1,000 dreamers and keeps the light of these stories alive. Together we wander, not to conquer, but to understand.